Odhayan Academy is dedicated to bringing interesting lectures with solved example questions on a variety of subjects with critical concepts. For topic-based worksheets with detailed solutions, go to our website, odhayan.com. If you enjoy our videos, please like, share, and subscribe. In this video, we're going to be discussing Question 3, year 2011, variant 4-3, October-November. So first, we've been asked to define simple harmonic motion. For part B, we say that a horizontal plate is vibrating vertically, as shown in figure 3.1. From the figure, we can see that the mass of the cube on the plate is 5.8 grams, and the vertical oscillation frequency is 4.5 Hertz. The plate undergoes simple harmonic motion with a frequency of 4.5 Hertz and amplitude 3 millimeters. Okay, so assuming that this is its equilibrium position, we can say that its amplitude 3 millimeter, this direction and this direction. Now they want us to calculate the energy of oscillation for the cube. So here they want total energy. To calculate total energy, we have to first write its formula. So half m v naught square. But we don't know what v naught is. V naught is the maximum velocity. But we know how we can find maximum velocity using another equation. V naught is equals to omega x. But then again, we don't know what omega is, but we know how to find omega in terms of frequency, 2 pi f. Now we can substitute these two equations into the formula. To write half m omega x naught whole square equals to half m 2 pi f x naught whole square. So let's write down the values. 8 times 10 to the power 3 into 2 pi times 4.5 3 times 10 to the power minus 3 whole square, because the maximum displacement was 3 millimeters, so we have to convert it into meters. We get the total energy to be 2.1 times 10 to the power minus 5 joules. Now we have to keep the value in two significant figures because we were given our data in two significant figures throughout the whole question. Therefore, the answer is 2.1 times 10 to the power minus 5. Now in part C, they say that the amplitude of oscillation of plate in B is gradually increased, meaning that instead of using 3 millimeters, they're using values that are greater than 3 millimeters. However, they say that the frequency remains constant. At one particular amplitude, the cube just loses contact momentarily with the plate. State the position of the plate in its oscillation at the point when the cube loses contact. If you imagine holding a small eraser on your palm and you bounce the eraser on your palm up and down, up and down, at one point you will notice that when your hand is moving upwards, there will be a moment where if you can move your hand up and down strongly enough, the eraser will lose contact with your palm and rise up a little bit until it falls back down on your palm. So that is the moment that they're talking about in part C1. So we can say that the cube loses contact with the plate at maximum displacement, meaning when the palm is, instead of at this equilibrium position, the palm is over here. That is when you will notice the eraser to be flying up a bit. There will be a small gap between the palm and the hand. And at that moment, the palm is a certain distance away from the equilibrium position, or we can even call that the rest point. So the cube loses contact with the plate at maximum displacement when plate is above rest point, or we can call it equilibrium position. So for this question, the marks are distributed in two portions. First mark coming from the cube loses contact with the plate at maximum displacement. So that is 1 mark. And for the second mark, we write when plate is above rest point or equilibrium position. So that is how these 2 marks are distributed. In these types of questions, try to be as descriptive of the situation as possible, because you can understand that the cube loses contact with the plate at maximum displacement when the hand or when the plate is at maximum displacement. But we also have to mention that plate itself is above the rest point. It is further above the rest point. So try your best to explain such situations in as detailed as possible in the exam. Now in part 2, so they want us to find the amplitude of oscillation when there is this gap between the cube and the plate. But how can we do that? So we know a few equations. Can we use kinetic energy formula? But we don't know what the kinetic energy of the object is when it is detached. Do we? Don't. Can we use total energy? No. Gravitational energy? No. Then how do we find this amplitude? Well, there is an equation where we know that acceleration of an object is equals to minus omega square x naught. See, contains the maximum amplitude. But you might ask yourself, what is the acceleration of the object when it is detached from the plate? Well, it's very simple. The object is in free fall when it is detached from the plate. It is in free fall, so its acceleration is actually minus 9.81 meters per second square. It's in free fall. So we can just substitute that into the equation, saying minus 9.81 equals to minus omega square x. And for omega, we can simply use omega equals to 2 pi f, where we know that f, which has not changed, f is equals to 4.5. So for x naught, we can write minus 9.81 by minus 2 pi into 4.5 whole square, and we get the displacement to be 0.012 meters. So the amplitude where the cube is slightly detached from the plate is 0.012 meters. Once again, since the values we were given in the question, such as 4.5 is in 2SF, we must keep our answer in 2SF as well. Well, this is the end for this question. I hope you've understood all that has been explained in this question, and I hope to see you in the next video.